Hello, third graders. We are going to end the year with so much fun. We are going to make solar ovens. So before I get into the rest of the lesson, I want to tell you the supplies that you're going to need over the next couple of weeks. So you need a box, a shoe box, a pizza box, a nice big box that we can use, aluminum foil, some black construction paper, or you can paint the box black if you would like. We're going to find out why in just a minute. Some cloth, some kind of soft cloth, or maybe some bubble wrap. We'll find out about that in a little bit. And some tape. Now, we are going to make a solar oven so that we can make homemade s'mores. And we're going to make them without burning anything, right? We're just going to use the solar oven. We're going to use the heat from the sun. So for the s'mores, we need graham crackers, marshmallows. I would get the small ones, not the big ones, and a chocolate bar or two. Oh, this is going to be a delicious experiment. Okay, so now we're going to start talking about the science behind solar ovens. Okay, before we go on to learn more about solar ovens and how to make solar ovens and the things that we need to think about in our design, I want to make sure that you watch these videos on Brain Pop. I want you to watch the one on heat and the one on heat transfer, okay? So we all know what heat is, it's just like increase in temperature. But we need to know what's actually happening when things get hot and how does heat go from one place to another. So watch these Brain Pop videos and then we're gonna come back and talk about the things that we need to pay attention to when we're designing our solar oven. Okay, one of the first things I want us to talk about are some of the materials that we're going to use to build our solar oven. And we're going to talk about insulators versus conductors. Hey, remember when we talked about electricity? We talked about metal is a conductor. It conducts electricity. It passes the electrons on. Well, metal is also a great heat conductor. It passes the heat on from itself onto something else. So metal is a great conductor. Now, insulators. Remember when we talked about plastic was a great insulator? Well, plastic is an okay insulator for heat, but paper and cloth are even better. And even air is really great. And I want to give you a little example. Pretend it's winter and I'm cold. It's cold outside. And I put on a coat, right? So this coat is going to insulate me. It's going to keep my heat inside and it's going to keep the cold outside. So it's an insulator. Now remember when I said that air is a great insulator too? Well, I've got a different coat here. This one is a puffy coat, okay? It's got a lot of air trapped inside the coat. And this coat is actually better than my other coat because it's got pockets of air trapped all over inside. And the air helps keep my body heat in and it keeps the cold out. So we want to kind of think about these ideas when we're talking about our solar oven, okay? So we need insulation. We need to keep the heat inside the oven and any of the cold outside of the oven. So as you can see, this coat has got a lot of air in it. So we want maybe something that has some pockets of air. That might be a possibility. Or we could also just use cloth. Cloth is very useful for that. Another thing that's very useful for insulation is paper. Paper is a great insulator. And cardboard is especially very good. And I'm going to show you why in just a second. Okay, I want you to look really closely at this cardboard. Do you see how that there's two pieces of cardboard on the outside, and then there's a little triangular piece that goes between, it kind of weaves between them, and then there's space, and in that space is some air. and the air is trapped there and provides some insulation. I also want to talk about using air to insulate the earth. So look here, this is just a picture of the earth, but one of the things that surrounds our planet is an atmosphere which is made up of air. All kinds of gases, nitrogen gas, oxygen gas, carbon dioxide gas, argon gas, different gases. And those gases help keep the heat inside our planet, to warm our planet. If we did not have an atmosphere, if we did not have any air surrounding our planet, we would not have this nice warm environment. So air is a great insulator. Okay, so now I want to talk a little bit about conductors. I have a metal pan here. When I cook dinner, I use metal pans, metal dishes, metal skillets. So just like with electricity, metal was a conductor of the electricity, metal is a conductor of heat. So what we want to do, we want to think about when we're making our solar oven is to make sure we have something that holds in the heat, an insulator, and then something that conducts the heat from the sun and gives it to our delicious s'mores that we're going to be making. Okay, so I feel like we've made a lot of progress. We know about insulators, we know about conductors. Now we need to talk about some other things that are important to the design of our oven. Okay, so the next thing that I want to explore is to find out if different colors absorb heat or reflect heat more than others. So I'm going to go outside and I'm going to use 2 thermometers and I'm going to use some different colored paper, and I'll show you more about that later. And then we want to talk about reflecting heat. So I don't know if you've ever seen it, like when you put, your parents sometimes might have something that they put on the window to keep the heat from going into their car. And a lot of times those windows have like a shiny surface. And remember in first grade when we talked about light and reflecting light? Like a mirror reflects light. Light is a type of energy, and heat is also a type of energy. And you can reflect light and heat using shiny materials. So let's go out and see if there's a difference in temperature based on the color of some materials. So the first thing I want to do is I want to see if the color of a material makes a difference in how it absorbs heat from the sun. So I have 2 thermometers here. I have a piece of white paper and a piece of black paper. And I'm going to take them outside and I'm going to put them both side by side I'm going to put a thermometer on the black paper, a thermometer on the white paper, and I'm going to see if the color of the material makes a difference on how hot, how much heat is absorbed from the sun. Okay, so boys and girls, I have my thermometer on white paper and I have the thermometer on black paper. And right now, I'm just getting them started. Whoops! I put this paper down, some things down to weigh down the paper, but it's blown away a little bit. So now I'm going to wait about 5 minutes, and I'm going to come back and see what the temperature difference is. Okay, so boys and girls, I don't know if you can see this, but the temperature on this one is about 40 degrees Celsius. And this is the one on the white paper. Okay, the one on the black paper is 45 degrees Celsius. So it certainly seems like having a white background versus a black background makes a difference in how much heat is absorbed from the sun. All right, so we have some data back from our science experiment outside in the sun. And we discovered that black paper absorbs more heat than white paper. The black paper the thermometer on the black paper got up to 45 degrees Celsius. And the thermometer on the white paper got up to 40 degrees Celsius. So boys and girls, that's a significant difference. And if the purpose of us making a solar oven is to get the oven as hot as possible, then we want to consider what color we're going to make the outside of the oven, because we want that oven to absorb as much heat from the sun as we can. Okay, so now I think we've got a bunch of different information. We know materials that insulate. We know materials that absorb heat. And now I think we can start coming up with some ideas of how to build our solar oven. Okay, so third graders, I've got some ideas for my solar oven plan. So kind of using what we've already talked about in terms of our science, right, about absorbing and conducting and insulating. So what I'm going to do is have like a shoebox. That's what I'm thinking. I have some shoe boxes. I'm going to use that. And on the inside of the shoebox, on the bottom, I'm going to put black construction paper, okay? Because I want that to get hot. On the inside of the shoebox, on the sides, all around the sides, I'm going to put some bubble wrap. Remember we talked about air really is a good insulator? So I'm going to put some bubble wrap, and then on the inside of it, I'm going to put some cloth or maybe some cardboard, okay? And then I am going to either paint the outside of my shoebox black, or I'm going to put some black construction paper around it so it's really dark colors, okay? Now, I can't just have a black box. I want the light to go in, so I'm going to have the tops open, and I'm going to put some aluminum foil on the top of the box, and so it reflects some of the light and heat down into the box. But I don't want the hot air to leave the box, so I'm going to put a clear plastic something here so that the light and the heat can go in but then get trapped inside. Okay, so this is my plan. I might change it a little bit as we go along, but I need to have a plan. You guys need to have a plan as well. So this is kind of what I'm thinking about for my solar oven, and I can't wait to start building it.